Hi there. I'll be going over a couple of our models for the recommender system. Um, First, content-based filtering. So here we have a matrix of a bunch of feature vectors for every single movie. So here we have Toy Story, and all of these feature vectors essentially make up what Toy Story is, right? If it's a film from the 1990s, then the 1990s feature might have a high value, like 0.9 or something. But you see here in 1930s or 1950s, it's not very much related to those features, so it's pretty low on the with respect to those specific features. Um, for content-based filtering, though, we'll want an item-to-item matrix so that we can have uh, a ranking of all the films for every specific film. Um, we'll need some matrix which defines the similarity between every pair of features, and we can use the similarity matrix to rank recommendations for any film that we query. That will be a pretty dense matrix, but it will be really fast to get recommendations. So how can we fill out this matrix? We can use a dot product to find the similarity between any two films. So for Toy Story and Bugs Life, those films are somewhat similar, both children's films. You have a dot product of 63.6, and then comparing that with Toy Story and The Exorcist, you have 46.3, sufficiently lower than the above example. Okay, so problem with the dot product is that dot product is prone to favoring feature-dominant movie vectors. So films that just have lots of different genres or tags associated with them. So a film that has aspects of being a horror and a drama and a comedy, films like that, as opposed to films that are just, very strict and specific. This is just a family comedy, and that's it. So the films with those features that are, combinations of so many different genres, those will outweigh films whose feature vectors only consist of a few features. And that's an issue because then you get the same recommendations for every single film. And so solutions are you can normalize each vector and then apply the dot product. And this is what I did initially, but it was really not as computationally efficient as I wanted to. So here you see it works, but it's only somewhat efficient. Cosine similarity, this works and is super efficient and is what is used often after I did some more research. And then clustering works, but is not efficient. And then of course you can use some other any distance metric as well. So you could use like Euclidean distance, I don't know, Minkowski distance if you wanted really, whatever you wanted to relate one vector to another. But I didn't try it because it's probably not very efficient at all. For cosine similarity, here's what it would look like. Here's a formula and what we get back for Toy Story and A Bug's Life, 0.95. Moving forward, we can fill out the entire matrix just using this very simple call, just by using the import from sklearn. And then this is great because look at all these great recommendations. You can see for Toy Story, you get Monsters Inc., Toy Story 2, A Bug's Life, Toy Story 3. Like those are all fitting recommendations. However, look at the size of the file as well. We have a 5 gigabyte file because this file is huge. But it does query very quickly. So that is a benefit here. Users, right? So can we add users to make this better, right? To get better recommendations, because we do have that user data. So that's when we get to hybrid filtering. So using the same methodology for item-to-item filtering, we could essentially make a user feature vector where we create a linear combination of the rated feature or the rated movies by taking each of the movie feature vectors and then combining them, weighting by rating to get some sort of user vector that we can then compare to all the other films and say, okay, this film is close to this user, right? They both, this film is a 1970s film and this user tends to like 1970s films, things like that. It is pretty computationally intensive because for every user, you're having to calculate that same cosine similarity matrix. And I've thought of ways to kind of circumvent this so that you could do it all in batch, but it's pretty difficult. You can also use sparse tensors, and that ended up helping a lot, but then you lose a little interpretability. Anyway, this is the process. You get your cosine similarity. You scale that cosine similarity, And then you get some sort of rating, maybe, right? Because I'm scaling it between 0 and 5 so that I can distribute those similarity scores between 0 and 5, where I can have my 5 be 5 stars and my 0 be 0 stars. Unfortunately, as you see on the right, we have a normal distribution. And if you know a lot about rating statistics, you'll know that they're seldom ever normal because they often look like this. Either a U-shaped or a J-shaped distribution, because most people like to rate things, 5 if they really liked it, or 0 because they hated it. And things that are mediocre, well, they couldn't be bothered, right? So that's the main issue here. I was trying to figure out how to do certain skews. As you can see, like you can do log transformation to skew negatively, and that might help. But then you don't have any zeros, right? So I was trying to think of a way to get like a U-shaped distribution, but I couldn't find anything even in all the literature I was reading. Maybe I need to brush up on my stats a bit more. Yeah, so here we have specific user ID, so for 1, and then how the process would go is that we would omit some of those ratings and then have our model try to calculate those ratings, right, to fill in those blanks. And then based off that, we would score using the root mean squared error. And whoops, there we go. For I think like a 5,000 sample set, we got root mean square error of about 0.97. So it's about a single star off of the 5-star ratings most of the time. This is not great, but it's not terrible. Like our root mean square error of like 3 would be really bad because it would basically mean like it's no better than kind of guessing. And so, yeah, this is essentially the results of the combination of this content-based filtering as well as throwing in some user information, the user ratings. And here we have recommendations for user 9171, just a specific user we pulled out so we can compare across models. Thank you.